Hey YouTube, this is diveflyfish. Just want to show you my vacuum chamber. This essentially was a $12 water canister filter element that I got at a local farm and fleet. And you know, it's very, very robust, thick plastic with a nice O-ring, so I couldn't machine something like that for $12. All I did was I took like a spigot. I have a little through the housing electrical connector that I double sealed with some glue. I have a little brass nipple here, and then I have the leads that come out of the bottom of this that I can attach to a tiny cell. And this is one of those little cells that I made, and I'm going to attach the electrical leads, and we'll run some tests on it. So I'll try to get this so you can see what I'm doing here. Prop it up, and what I will simply do is hook up that lead. So now through this chamber we can put this in there and register a voltage. So I will do that, and once I get it situated and sealed up, I'll take a measurement and we'll go from there. So that's step one. Okay guys, this is step two. You can see the voltage that I'm registering off of here. Here are the leads coming out of the top of this chamber. Here I have the plastic going into a brake line vacuum that registers to minus to 30 inches mercury. So in any event, I can either do this as a positive pressure or a negative pressure type situation. So I'm going to be draining all the air out of this, and we're going to achieve a stable, hopefully 30 inches of mercury on this chamber, and we'll see if there's been any alteration in voltage, and then we'll check current. Oh, I might as well check current right now as we're at it. So just to see where we're at, I'll take a microamp reading here, and actually I'll change it to milliamps. So that's what the cell's producing, draining down a little bit. Let's see where it stabilizes to. Probably going to stabilize around 2 to 3. So it's starting to slow down a bit. So in any event, what we'll do is, what I'm looking for is if there's any type of change. Right now it's draining, so when we apply a vacuum and applying stress to the crystal, it may pull some air bubbles out, which could impart a stress. So we'll find out. I'm just going to leave it on the current for right now. I'm going to start to draw down the housing, and we'll go from there. Okay guys, I'm starting to draw down the housing, as it were. Right now I have it at, it's about 5 inches of mercury, and I'll keep on drawing it down. Let's see if we're seeing any change in current flow. Now we're at about 10 inches, or pardon me, 10 inches of mercury, not millimeters, 10 inches. So here we have vacuum pressure. Current still is dropping, so I'm just going to stop filming for a minute so I can draw this all the way down. We're about 14 inches of mercury. So we'll take it down and then we'll go from there. Okay YouTube, I've got this drawn down to 25 inches of mercury, and this is where it's registering as far as current, 1.47. So what I'm going to do now, it stabilized right about that level, which is much lower than what I was registering when it wasn't in this environment. So I have a little lever here that I can decompress this, and we can see what happens with the voltage. And I'll see if we can videotape changes. Here we go. So 1.48, I'm around 24 millimeters of mercury, or 24 inches of mercury. Let's see if that changes when I start to decompress this, if there's any change in voltage. Here we go. So there you go, the rate change. Now let's see if it stabilizes and goes back down again. That's still going up. That's very fascinating. So in any event, that was a vacuum down to 25 millimeters of mercury, and we'll go from there. Now, it should be interesting to do the flip side of that equation and pressurize it, and that will be the next test. So if nothing else, it's the milliamp hours are going up, after decompression goes down with an increase in vacuum. So you might find that interesting. More experiments next with pressurization. Give this a diveflyfish. Just want to show you this is going to be the positive pressure test. Got a bicycle pump here, and I'm going to take it up to let's say the equivalent of, I don't know, 30-40 psi. See what this thing does from a current standpoint. And again, you can see here we are roughly at 2 milliamps, and we'll start pressurizing as soon as I get the seal proper. So I'll be back with you in a second. Okay, IB, this one's for you. But suffice to say, increase in pressure definitely does increase current flow. So we have 2.84 milliamps. We are now at approximately excuse me, 30 psi almost. So see what we can go. So there is 3 milliamps in holding. We're about 40 psi. So that's about 50 psi. I don't want to go much higher than that, but it's holding. So now let's see if it continues to climb or if it stabilizes or decreases. So it's still roughly stabilizing there. So hyperbaric definitely increases current production. Phenomenal. And she's still rising. Again, it's just a bicycle pump here. We are at approximately 50 psi. A little bit under, but the current's still climbing, and I'm not pumping anymore. So, in any event, let's see what the decompression will do. So I have this little spigot here, okay? So we're going to vent some pressure, and let's see if it's a rate change that affects a change in current levels as well. So here we go. Try that again. So now we're back to normal. Start pumping this back up. So there we are at about 40 psi again. So it's reproducible. Now we're back up to almost just shy of 50. Excuse me. So we're at 50 psi, and there's the current, 3.1 milliamps, not microamps, milliamps. Decompress it again, see if we see it to climb again. Okay, here we go, ready? It seems to be hanging up higher there. Sort of interesting. So, maybe there's something to be said for fabricating these cells and having the final crystallization occur under hyperbaric environments to make a more dense crystalline lattice. And I actually think, the more I think about that, that may actually be a benefit. So being able to allow this to cure under pressure may be interesting to see what it does. So for what it's worth, again, that's just a water softener, Omni filter. It's like $12 for the canister, and miscellaneous plumbing that I had around the house. So again, the current's decreasing. We're back down to ambient. Okay, and we'll go from there. Very, very interesting. Very, very interesting. Have a great night.